Partial Differentiation Introduction and Solution to Basic Problems.
Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir. Today in this video, we are beginning a brand new chapter, Partial Differentiation, one of the most important chapters in the Module 2 of the VTU Engineering Mathematics 1 syllabus. Today, I will explain the concept in a very simple way and solve some basic problems to build a stronger foundation. Later in this series, we will cover the higher order partial derivatives, composite or chain rule problems, the Jacobians, maximum minima, etc. See friends, this concept partial differentiation is very crucial with respect to the examination point of view, as you can surely expect 12 to 14 marks question from this concept. So please don't attempt to skip the video, watch this video till the end, and please practice to make a better understanding of this concept and to score good marks in the examination. So what actually partial differentiation is? See, ordinary differentiation deals with only one variable x or y, that's it. But partial differentiation deals with functions of multiple variables, say u of xy, f of xy, so on. Partial derivative focuses on differentiation of a function with respect to one variable, keeping the other variable constant. Let us see, let's say u is a function of x and y. When we differentiate with respect to x partially, we write it as dou u by dou x. Okay, when we find dou u by dou x, we differentiate only with respect to x, keeping y constant. And when we differentiate with respect to y, we write it as dou u by dou y. Here, we differentiate only with respect to y, keeping the x constant. In a very simple way, say if I give you an apple and a banana, it's a simple example to relate. Strictly I tell, eat only apple. Then what you will do? If you are listening to me, you will keep a banana with you, but eat only apple. You will not touch the banana. Getting it? Getting the point? But if I tell you eat banana, there are only two things, apple and banana. Then obviously you eat the banana, you keep the apple as it is. That's what we are doing here. When I tell you strictly partial differentiation means I'm warning you, I'm instructing you to differentiate only with respect to x. It means you are not going to touch the y terms, y is a constant, you are differentiating only x. When I tell you to differentiate y, you are touching only the y terms. X terms, you don't touch it. X is treated as constant. That's it. So let us understand this simple concept in a very simple way, solving some basic problems on the board. Okay. And friends, before solving these problems, please don't forget to like, share and subscribe. In spite of my present health conditions and health challenges, I am committed to bringing more and more useful, high quality YouTube engineering content for you. It's your support that keeps me motivated. So let's start solving this problems, understanding how the partial differentiation works in a very simple way. Now, before moving on with the problems, let's discuss some basic stuff here. Please understand this. Now, if I say if u is a function of x and y, say f of x comma y. Okay. Now, say we are partially differentiating here with respect to x. Partially differentiate with respect to x. Then we write that as ux is equal to, what is that? Ux is equal to, we write as dou u by dou x. See this. How we represent, how we pronounce dou u by dou x. Ux is dou u by dou x. Also, uy means we are partially differentiating with respect to y. Dou u by dou x, we are partially differentiating with respect to x, keeping y constant. Dou u by dou y, that means we are partially differentiating with respect to y, keeping x constant. Again, the second order derivative for this will be, again differentiate, ux becomes u double x. This is how we denote it. Some textbook refer it as fx, f double x one. So since I take the function as u here, I am writing ux uy, and this higher order derivative will be u double x is equal to, again dou by dou x, again partial differentiation to x, dou u by dou x, that becomes del square u or dou square u by dou x square. Getting it? Ux is dou by dou x, u double x, dou square u by dou x square. Similarly, the higher order derivative of uy, again differentiate uy with respect to y. So, u double y will be dou by dou y of dou u by dou y, that will be dou square u by dou y square. And one more, the mixed derivative will be, say I can write u x y, that means you are differentiating what? U x y, see x then y, that means dou by dou x of, you are differentiating dou u by dou y, dou x y, x coming for, that means you are differentiating dou u by dou y with respect to x, that is nothing but dou square u by dou x into dou y, right. Similarly, we can write u y x is equal to, here see x comes second, it means dou by y, means it is dou by dou y of dou u by dou x, that means you are differentiating dou u by dou x with respect to y, x, yes, y, y, getting it. So, we write this as dou square u by dou square into dou square u by dou y into dou x. And one more important thing to remember is that always u x y will be equal to u of y into x, that is dou square u by dou x y is always equal to dou square u by dou y into dou x. This is the basic things you need to remember, the conventions while solving the problems. So, what is that? How we denote the differentiation? Partial differentiation, differentiation d, but partial is dou, dou u by dou x, dou u by dou y, dou square u by dou square, dou square u by dou y square, so on. That is it. So, now let us start with this concept, let us start solving the problems. Now, to make the concept of partial differentiation more and more simple, so that it easily fits in a brain, we will solve some simple questions here now. Okay, this will help you to make us make your foundation stronger, and the later problems you will solve easily. So, let us take let u is equal to say x cube plus say y cube plus x square y cube. This is a question. Now, I tell you, partially differentiate with respect to x, that means what is that? Dou u by dou x or ux is equal to, so what is that? Remember the example of apple and banana. I give you apple and banana, ask you to eat apple, don't touch the banana, keep as it is, eat only the apple. Here I am telling x and y, I am telling differentiate, strictly I am wanting differentiate only with respect to x, don't touch the y's. It means, see, x square is, x cube is here, am I right? X cube is here, correct. So, dou u by dou x means partially differentiate only with respect to x, x cube is what? 3x square, y is constant. What is differential constant? 0, leave it, plus, I write here 0, plus, here again differentiate with x only, so y cube you don't touch it, keep it's multiplied. See, you know, differential of ax is, we don't make it 0, as you know, differential a is 0, but differential a into x will be a as it is, x is 1. So, here also, since y cube is a constant, it's just multiplied, so keep as it is, differential only x square is nothing but 2x, that's it. And say dou u by dou y means here partially differentiate with respect to y, eat only banana, keep the apple with you, eat only banana, that means y, only y terms. So, what is that? X 0 constant, y cube is here, so differential will be what? 3y square plus, only with respect to y, x square don't touch it, differentiation of y cube is what? 3y square, that's it, that's how it works. Let us do some random example again. This is one question, let us take a random question, say u is equal to sin x into cos y. What is u is equal to, say, sin x into cos y. I am following these random questions, they are not from any textbook and all. Now, again I tell ux, that is dou u by dou x, differentiate only with respect to x, only x is multiplied. If it was plus, sin x plus cos y, different, then obviously dou u by dou x will be cos y 0, only sin x cos y, but here multiplied. cos y is constant, don't touch it. Dou u by dou x, only differentiate respect to x. Sin x is what? Cos x. Similarly, dou u by dou y is equal to, say, only y terms. Sin x, don't touch it as it is. Differentiation of cos y is how much? Minus sin y. So, minus sin y, that's it. Like this is how it is done. So, I can take one more question, say, last question for it to solve. Let me take a concept question as say, u is equal to e raised to x into cos y plus say x cube log y plus say y plus say x square, say something random question. I write say dou u by dou x is equal to, tell me what? Partially differentiate only with respect to x, again cos y as it is, don't touch it, differentiate e raised to x only, done. Again x cube is here and here also. Okay, so plus log y, don't touch it as it is, I'm not touching it. Dou u by x, only differentiate x cube will be what? 3x square plus again y, there is no x in there, y is a constant and differential constant is what? 0. So 0 plus x square is that 2x, that's it. Similarly, I can write dou u by dou y is equal to, finally here I am partially differentiating with respect to y. So see, y is here and y is here and y is here, right? That means e raised to x as it is, don't touch it, keep it as it is, don't touch it. Differentiate only with respect to y, cos y is minus sin y, x cube, don't touch it, only with respect to y, dou u by dou y, log y is what? Log is 1 by x, log y is 1 by y, so upon y and plus y, dou u by dou y, differential y is 1 plus 1 x square, no y term, 0. This is how it is done. So I explained in a very simple way and I am 100% sure that you understood what does partial differentiation means and you understood how to solve the problems here. So with this concept we will be solving more and more higher order problems now. So please understand once again, watch the video again so that you don't make mistakes further. Okay. So let's solve this question here. This question carries 6 marks and has been repeatedly asked in the VTU examination. It says, if u is equal to e raised to x plus by into f of ax minus by, prove that b dou e by dou x plus a dou e by dou y is equal to I b into u, to our rule. So now how to solve this? So first let's write this function, u is equal to e raised to x plus by into f of ax minus by, fine. So we need dou e by dou x, that means we need to partially differentiate respect to x. So we write dou u by dou x is equal to, now if you see here, x is here, x is here, that means it's nothing but into means product rule. So what is product rule? Differentiation of first into second function is first function as it is into differentiate second plus keep the second function as it is into differentiate first. So here's the same thing I do, because x is here, exponential and other function. So we need a product rule here. So e raised to x plus by keep as it is. Now here you are differentiating f of ax minus by only with respect to what? X. So what is this f? It is f dash of ax minus by. Again chain rule also follows. It's not simple as f of something, again differentiation of that chain ax minus by with respect to only x. ax differentiation is what? Into a, that's it. Getting it? Next, plus again f of ax minus by as it is, product rule, differentiation of first function, differentiation of e raised to x is e raised to x only. So e raised to x plus by will be e raised to x plus by only. But since we are differentiating again only with respect to x, so again chain rule, differentiation of x plus by is 0, differentiation of x will be into a, that's it. Now dou e by dou y. So dou u by dou y will be now again same. See here, see here carefully, y is here and y is here. So again it is a product rule. So we have for the same thing here, keep the first function e raised to x plus by as it is. Now differentiation of f is f dash ax minus by. Again see here you are partial differentiating with respect to y, x is constant. So f of f dash of x minus by, again differentiation of ax minus by with respect to y, ax is 0, differential minus by is y is 1, so it is nothing but minus b, you put a bracket here, plus f of ax minus by as it is into differentiation of e raised to ax plus by with respect to y will be, see differentiation of e raised to x plus by will be e raised to x plus by only. Okay, but again chain rule, since we are differentiating here with respect to y, differentiation of ax is 0, x is constant, plus differentiation of by with respect to y is into b. Now what they are asking? They are asking that implies b, we have b dou u by dou x plus a dou u by dou y equals, so b, multiply this whole equation by b, dou u by dou x is here, I need b into dou u by dou x, so multiply the whole equation by b times dou u by dou x. So I write a constant first, this will be ab into e raised to x plus by f dash of ax minus by, again into b, a into b plus a b f of x minus by into e raised to x plus by, again plus a into dou u by dou y, dou u by dou y, so a times dou u by dou y, so plus, if I multiply here a into, see here I am multiplying dou u by dou y towards a to prove this relationship. So minus b is there, so this will be minus ab, okay, plus minus ab, fine, into e raised to x plus by into again f dash of ax minus by, and here a into b as it is ab, again plus ab f of ax minus by into e raised to x plus by. Now this looks like a simultaneous equation. See here, ab e raised to x plus by df dash of x minus by minus ab e raised to x plus by into f dash of x plus by. They both cancels off when you add them. So this both cancels. Okay, so what remains is that, therefore, if I write, this implies b dou u by dou x plus a dou u by dou y is equal to, this cancels, what remains, ab plus ab is what, 2ab. So 2ab into I write this first term e raised to x plus by into f of x minus by. But what is e raised to x plus by into f of x plus by? Here, see the question, x u e raised to x plus by into f of x minus by is nothing but u. That implies, therefore you can write b dou u by dou x plus a dou u by dou y equals to 2 into, what's that, ab into what is e raised to x plus by into f of x minus by is nothing but from the question u into u. That's what they want us to prove. So b dou u by dou x plus a dou u by dou y is equal to nothing but 2ab u. That's the answer which they need. That's okay. I hope you understood clearly how to solve this. The next question here is also equally important. It says, if u is equal to f of x plus ct plus g of x minus ct, prove that u double t is equal to c square u double x. See, what we need to prove here now, as we discussed in the basic, u, ux, higher order u double x, so on. ut, here the variables are x and t, there is no x and y here, The variables are what? X and t here. So, in other way we need to prove nothing but u double t is what? Dou square u by dou t square. Ut is dou by dou t, u double t you need to prove that is equal to c square into dou square u by dou x square. That's it. Let's prove like this. Okay. So let me write a question here. U is equal to f of x plus ct plus g into x minus ct. So what we need here? Dou square u by dou t square. As we discussed in the basics, ux higher derivative u double x, ut dou u by dou t higher derivative u double t dou square u by dou t square. Okay, so first we need to find what? Dou u by dou t, because see there are only two variables here, x and t, there is no x and y, x and t. So first we will partially differentiate with respect to t. So ut will be dou u by dou t. You are differentiating only with respect to t here. Okay, so differentiation f is f dash of x plus ct. Again, differentiation of f of x is f dash x. It's not plain as x plus ct. Again the chain rule. Again differentiation of x plus ct with respect to t is x is 0, ct differential ct with respect to t is differential t is 1 into c. That's it. Again g dash of x minus ct, differential of g of x minus ct with respect to t is for g dash. Again differential x minus ct with respect to t is x is 0, differential minus ct is what? T is 1, again minus c. That's it. Now u double t will be what? Dou by dou t of dou u by dou t, that is dou square u by dou t square is equal to. Okay, that means what you differentiated with respect to t, again you need to do one more time with respect to t, that is dou square u by dou t square. So again this one will differentiate again with respect to t. So again see as it is, again f differentiation f dash is f double dash f plus ct. Again differentiation x is 0 with respect to t we are doing, ct differentiation c, c into this c becomes what? C square. Again minus c into again g dash is d, double dash of x minus ct, right? X minus ct. Again with respect to t, x is 0, differential minus ct is minus c. Minus c into minus c becomes what? Plus c square. That's it. This is what we get. So we have the first one here, dou square by dou t square. Okay, let's take it here. I will take this as say first number 1. Now dou square by dou square means ux u double x, dou square by dou square. First find dou by dou x, that is ux is equal to now dou u by dou x. We are partially differentiating here only with respect to x. Again differentiation f is f dash of x plus ct. Again differentiation of x plus ct with respect to what? X. See x is here, x plus ct, t is 0, differentiation x is what? 1. Leave it as it is. Again plus differentiation of g is g dash of x minus ct. Again differentiation x is 1. That's it. Next u double x is equal to dou by dou x of dou u by dou x, that's equal to dou square u by dou x square. That means what we have differentiated with respect to x, again double differentiate with respect to x. It's a very simple process now. I hope we are getting it clear. Again this will be differential f is what? F dash is f double dash of x plus ct. Again the same thing repeats. It's only different. X is 1 if apart from x it was 2x into 2, cx into c so on. But x is only once. Different x is what? 1. That's it. Okay. Again plus g double dash of x minus ct into again differential x is 1. That's it. Now what we need? C square, we need to show dou square u by dou t square is equal to c square dou u by dou x square, or u double t is equal to c square double x. So I have u double x, so I'll simply multiply with c square here. So that implies c square into u double x is equal to, see simply multiply it here, we get c square into f double dash of x plus ct plus c square into g double dash of x minus ct. That's it. I'll take this as equation 2. Now compare both from equation 1 and 2. See c square, x plus ct, c square, g double dash x minus ct, that's both are same. Therefore, from 1 and 2 we can write what? Dou square u by dou t square equal to c square dou square u by dou square. Dou square u by dou t square is equal to c square dou square u by dou x square, or as they asked in the question, u double t is equal to c square u double x. That's the solution. That's it, as simple as that. I hope you got it clear. So that's all for today. I am sure that you have clearly and very clearly understood how the partial differentiation works, and with the examples which are solved, you will be able to understand it in a better way, and you will be able to solve more problems from your textbooks. Okay, in the next class, we will be doing a few more very important examination based problems on same partial differentiation. So, if you find this video helpful and you like the way I teach, then please drop a comment below with your doubts and suggestions. Subscribe and hit the bell icon so that you don't miss the next tutorials. Thanks for watching. See you in the next one. Till then, bye.